Hi students, so we are going to our next topic, that is, as I discussed, stoichiometry. I can say this is the crux of whole chapter actually, because from this surely you will get a question, there is no doubt in that. We have learned all the basic stuffs to understand this one actually. So first I will give the basic definition and understanding, and after that I will give you an example or a real life example that will help you to calculate all stoichiometry related questions. Surely I can guarantee you will understand. That is the way we used to handle this here. Okay, so listen. So what is stoichiometry means? The word stoichiometry is derived from two terms. So stoichion means element and metron means measure. That is, you are measuring the element basically. Okay, so basically the definition, if you speak, calculation based on the quantitative relation. This quantitative relation we have learned. Quantity can be represented in, number of moles, number of gram atoms, number of atoms, or it can be represented in volume and these many terms, So that is the calculation based on the quantitative relationship between the reactants and the products is referred to as stoichiometry. Okay, so what are the steps involved in this? So I am just first telling that I am sure if I am tell these steps in first single shot you won't understand. But please remember, just I am telling this, thereafter I will explain. Okay, so the first step is, whenever if a stoichiometry related question is there, you need to understand what are the reactants and what are the products. If the equation is given in the question, well and good, you need to balance it. That is the only thing you need to do. If the equation is not given, for example, they are telling hydrogen and oxygen react to form water, you need to write the equation. Okay, that is also NCERT is telling, or our syllabus is telling. Okay, so first step is writing the equation. Then the next step is writing the balanced chemical equation, making it balanced. Okay, if you in the first step itself you are writing the balanced chemical equation, well and good, that is what expected. In the next step, what we are going to do, from step 1, write the molar ratio between the given required substance. So write upon the molar ratio. I will explain what is this molar ratio, and this ratio we can call it as even the stoichiometric ratio as well. I will explain that. Now convert these moles into desired parameters. Next step, we are converting the moles into desired parameters. Why we are saying we need to convert these moles into desired parameters? Because in question they may not be asking you the moles. They can ask you many things actually. They can give you the number of moles, they can give you, or they can ask you the mass, they can ask you the number of gram atoms, or they can ask you the volume. We have learned many terms, right? So all those things they can ask. So but fundamentally what we are doing, we are first finding the number of moles and getting converted into the desired parameter what they have asked in the question. Okay, so first we will discuss how to do this. I will first explain with an example with a chemical equation, then I will relate with a real life example. With that you will understand the stoichiometry concept. Okay, so listen here, just I am rubbing the board. I hope you could see it now. Okay, so for an example I am taking our fundamental example, hydrogen H2 plus O2 giving you H2O. This is one example I am taking, and we know this also, nitrogen N2 plus H2 giving NH3, ammonia. Okay, this is all in gas. Fine. Okay, you could see this example. So now here first thing I have got written here is an equation, correct, a chemical equation. But whether it is balanced, you know that it is not balanced. So first step is balancing. So 2 hydrogen atoms, 2 oxygen atoms, but here 2 hydrogen atoms are there, only 1 oxygen atom is there. So if I put 2 here, what is the way? You know that this becomes 4 and hydrogen atoms, so I will put a 2 here. So I can say this has now become balanced. Correct. So first step is balancing. Okay. Okay, it has become balanced. Now next case you see nitrogen 2, hydrogen 2. Here 3 hydrogen atoms are there. So what I need to do? Nitrogen 2 is there. So I will put here 2. So now here also 2 has come. Now hydrogen becomes 3 into 2, 6. But here only 2 is there. So I will multiply by 3. 3 into 2, 6. So now this has also become balanced. Balanced. Correct. Now listen. We have made it balanced. Now we are going to write the stoichiometric ratio or the molar ratio. I can say that 2 hydrogen. So I can say this is 2 mole of hydrogen combining with 1 mole of oxygen forming 2 mole of water. So my molar ratio is 2:1:2. So this can be either called in 2 ways. This can be called as molar ratio, or I can say it as stoichiometric ratio. Very important. Similarly, here also I can say 1 mole combining with the 3 mole of hydrogen to form 2 mole of ammonia. So 1:3:2. Okay. So I can now here also I can say this is my molar ratio, or it can be called as stoichiometric ratio. Okay. So I hope you understood how to calculate this molar ratio or stoichiometric ratio. Earlier we used to say this as a stoichiometric ratio. Okay. So I am just made it balanced and told you this is my molar ratio or stoichiometric ratio. Now I want you to experience this in different formats. For example, now I am rubbing one example to make space in the board. Okay. Now listen. What are the different ways? You might have learned in different ways, right, of expressing an atom. For example, you know it's a molecule. So what are the different ways you have learned actually? You can express it in gram molecule. You can express it in mole. You can express that in mass, molecular mass. You can express that in number of gram, I have told. You can express it in volume. So different ways you can express it. Correct. So I will try to express this in different way so that you can understand how many possible questions can be derived out of this. Listen. So first I am writing this in my fundamental way, that is moles. So I can say here first format of representation. I can say 2 moles of hydrogen combine with 1 mole O2, 2 mole of hydrogen combines with the 1 mole of O2 to give 2 mole water. So now in terms of mole I have told 2 mole of hydrogen combines with 1 mole of oxygen to give 2 mole of water. What is the next way I can represent it? This one, since it is a molecule, I can say it in gram molecule, right? Number of gram molecules. So I can say, you know, 1 mole is equal to 1 gram molecule. So 2 mole is equal to 2 gram molecule. I can say 2 gram molecule. Again I am saying this is a single term. 2 gram molecule of hydrogen combines with 1 gram molecule oxygen to give 2 gram molecule, okay, again single term, water. So this is the second way of representation. Correct. Now what is the third way you can represent it? You know that this can be represented as number of molecules also. So I can say that 2 mole is equal to how many number of molecules? We know that 1 mole is Avogadro number of molecules. So 2 mole is equal to how many number of molecules? 2 into Avogadro number. So I can say 2 Avogadro, 2 into Na, or you can explicitly write 2 into 6.022 into 10 power 23. That is 12 into 10 power 23 molecules of hydrogen. You can write it like that, or you can say 2 Na molecules of hydrogen combines with, you know that 1 mole is equal to Avogadro Na molecule of oxygen to give, tell me, 2 mole of water. 2 mole of water means 2 into Avogadro number of water. So 2 Na molecules, 2 Na molecules of water. Okay, now I represented it in the third format. What is the fourth format? You can represent it in terms of mass, correct? So in terms of mass, how will you write this? I know that 1 mole is the mass of, or molecular mass is the mass of 1 mole, correct? So here 2 moles of hydrogen means what is the mass of hydrogen? Tell me. 1 mole of hydrogen, H2, has a mass of 2 gram. You remember in our first class we learned, correct? 1 mole is equal to molecular mass in grams. So 1 mole means of hydrogen means it is 2 into 1, 2 grams, since it is molecule. So 2 moles means it becomes 2 into 2, 4 grams. So I can write here the fourth way as 4 grams of hydrogen molecule can combine with, tell me here, 1 mole of oxygen. So 1 mole of oxygen has how much grams? We know 1 mole is molecular mass in grams. So O2 means 16. I can write 16 is the atomic mass. Here O2 is there, so it is molecular mass. 32 grams of oxygen to form, tell me, 2 moles of water. So 1 mole of water, what is its molecular mass in grams? We know molar mass, since it is in grams. I can say it is 18 gram, correct? So 2 moles means 36 gram. So 2 into 18, that is 36 grams of water, correct? Clear? So 4 ways I have written. Now what is the fifth way I can write it? Listen. You know, in terms of, since it is molecule, we can express this in volume also. So tell me, 2 moles of hydrogen means how much volume? 1 mole means 22.4 liter. So 2 mole means 2 into 22.4 liter. That is 44.8 liter. So I can write 44.8 liter of hydrogen, okay, can combine with, tell me, 1 mole of oxygen. Any gas, if it is 1 mole, it will occupy 22.4 liter. So I can write 44.8 liter of hydrogen can combine with 22.4 liter of oxygen to give. So if this is also in gas, think like it is in vapor state. You know that 2 mole of water. So 1 mole in vapor state, it will occupy 22.4 liter. And if it is 2 mole means it will occupy what? 22.4 into 2, that is 44.8 liter. So I can say 44.8 liter of water. And please remember at STP, very, very important. So we have tried to written in all the basic format. And let me tell how many questions can be derived out of this in your understanding. I can say many combinations. Why I am telling that? Because when 2 terms we are trying to relate, I have shown you how many questions can be derived. Now you listen here. They have given an equation consisting of 3 terms. Understood? 3 terms are there. Okay, terms can increase also. Now think of a situation. This is the fundamental equation, and for this reaction to happen, they are giving you some substance. That substance, for example, they are giving you hydrogen and oxygen for water to form. Okay, they have given to you, and this hydrogen and oxygen, they can given in the question in any terms. Suppose they will give hydrogen in mole and oxygen in gram molecule, and they will ask you water in number of molecules. Understood? Sometimes they will give hydrogen in gram molecule, water in mole, and the output product in mass. Or sometimes they give mass of hydrogen and oxygen they will give in volume, and they will ask you the number of molecules of water. You think about, with these 5 parameters, how many combinations can be made. It can be, I can tell simply, it can be mole, this can be given in mole, this can also be given in mole. So mole combination. They can give mole, with the next one, you can say number of molecules, mole with the number of molecules, or they can give mole with the mass in grams. So I am fixing one in mole and I am changing the other. Similarly, they can next thing will be I am fixing this as molecule and writing the other possible combinations. So if you do that, many questions can be derived. But it is not a problem for us. Whatever way they are giving, they are expressing it in mole or number of gram molecules or number of molecules, or whether it is in mass or whether it is in volume. We know how to interconvert between these terms. That is what we have learned in our initial classes. That is the reason why I told, if you know the initial classes, what you have listened to it, know that conversion. If you are given anything you know to convert to each other, then this becomes very simple. And now the question here is, sir, we know the interconversions also. So how to do this, sir? What you need to do is, in the question, suppose they are asking you the product, how much, if they are asking you the product, find out in what terms they are asking you, whether they are asking you the product in number of moles, or whether they are asking you the product in number of gram molecules, or whether they are asking you in number of molecules, or whether they are asking you in mass, or whether they are asking you in liters. First identify that. Suppose they can ask this also. It is not always sure that they will always ask you the product. They can ask you like this. Suppose they have given 2 mole of hydrogen and they say 4 moles of water is formed. How much moles of oxygen is required? Like that also they can ask. So what they are asking, identify that quantity, what they are asking. Here suppose it is product, means product. In what term it is asking? Then what you need to do, note that term, whether it is number of molecules or what. Okay, wait there. Then you first calculate everything in number of moles. That is, since you know the molar ratio or stoichiometric ratio, from this first you take the given substance, and convert that into moles first, and also calculate the product also in moles. Okay, now you know everything in moles. Then after doing that, convert that mole into desired parameter. That desired parameter can be number of gram molecules, or it can be number of molecules, or it can be mass, or it can be volume. Okay, so I have given a rough idea. Again I am telling, surely with this explanation you will not get a fair picture, but you should understand one thing out of this lecture, that is, you can create many possible questions out of this. So that I will explain one more time, and I will tell my real life example to make you understand this more. Okay, just listen. Okay, the step 1 is already completed, I have told. Now I am going to explain how many possible questions can be derived out of this. This is to make you feel actually. Okay, I have told it, but just showing it. Suppose think like the given, for you want to prepare water, they have given hydrogen in mole. And how many possible ways oxygen can be given? It can be given in mole, correct? Or it can be given as number of molecules, correct? Okay, so I will write below, then it becomes easy for you to, otherwise you get confused. So it can be number of molecules, okay, or it can be number of gram molecules, correct, or it can be, volume. They can give volume, or they can give mass. So they can give mole here and give mole here, or they can give mole here and they can give number of molecules, or like this combination. So tell me how many questions possible. Mole with this itself you can create mole number of molecules, mole number of gram molecules, mole volume, mole mass. So if you say 5 questions can be derived like this. 5 questions. And there is also other possibilities also. Now they have given in 5 possible ways, and they can ask you here, when mole and mole is given, they can ask you mole, correct? And if mole and mole is given, they can ask you number of molecules also. Okay, this is what you need to calculate, right? So given hydrogen in moles, oxygen in moles, and ask you to calculate the number of moles of water, or they can ask you number of moles of given the number of moles of hydrogen and number of moles of oxygen, and they can ask you to calculate the number of molecules of water. Like that, again 5 will come here. All these 5 will come here. Correct. So that means from this combination you can get 5 questions. From this combination you can get 5 questions. From this combination you can get 5. From this you can get 5. From this you can get 5. Correct. So 25 questions from the first possibility. Understood. Now taking the next combination, they can give the number of moles of hydrogen and number of molecules of oxygen and ask you to calculate the number of moles or number of molecules or number of gram molecules, number of calculate the volume or mass. So again 5 questions. So if you do this, I can say another 5, 5, 5, 5 combination will come. Okay, another 5, 5, 5. That is for this combination alone, 5. I am getting some 25 questions. So I will write that some 25 questions you will get. For this, now see here, making it more specific. Now I have the second combination like this. For this combination, like this combination. Okay. So this combination, I can get another 25. For this combination, I can get 25. This combination, I can get 25. And this combination, I can get 25. Okay. So it becomes 125 questions here. Now this is not finished. Now here I have fixed mole. Next here it can be number of molecules. Correct. And you can have mole, number of molecules, number of gram molecules, volume and mass here given. From that again it can be anything they can ask. So again this, what will happen? This 125 questions will come here. So 125 plus 125, 250. Again I am, for hydrogen I am making it number of gram molecules, another 125. That's why I told around some thousands of questions can be derived from 3 terms. Suppose now think of a situation where 4 terms are there in balanced chemical equation. So they can give it in anything. So don't think about the number of questions that is being derived here. Instead, always I have told as my solution, first check in the question what to calculate. Whether it is a reactant you need to calculate or the product you need to calculate. And take that parameter, note down that parameter and uncheck in which term you need to calculate. Whether you want to calculate that in number of moles or number of molecules or number of gram molecules or whether it is volume or it is mass. Okay, note down that. Then do the all calculation initially in number of moles. Then convert that moles into the desired parameter. That is it. Easy. Okay. I hope you got a fair idea regarding this. Now we will go to our real life example to make this more understandable. Okay. Hi students. So we were discussing the topic stoichiometry. So initially I have explained you what is stoichiometry in more a technical way. So now as I told, I will give you an information, I mean a real-time example to understand stoichiometry in a much better way. Okay. So I want every student to imagine a situation. Okay, very simple. Think like you have become doctor or engineer. Okay, now you are in your college days and almost 3 years is completed. Okay, and it is one Sunday I am speaking about. Okay, there is one Sunday and Saturday night you came to know that your parents are going to visit you at hostel. Okay, now think about this hostel, you need to prepare food your own, then only you can eat. So when you heard the news, when parents are coming to visit you, you thought of, okay, let's say parents are coming, so we will prepare a biryani. Okay, let it be chicken biryani. Okay, so you thought of doing it, making it very good so that your parents will also be impressed. So my son or daughter know how to prepare chicken biryani. Okay, so that you learned about it, how to make a chicken biryani. And after learning, you understood that to prepare one chicken biryani, I am saying about one chicken biryani, you need one chicken piece, minimum one chicken piece is required. that is 1 chicken piece makes 1 chicken biryani, and 1 kg rice is required. Okay, please imagine, it's just an imagination. 1 kg rice is required and 1 masala packet is required. So these three things, when you put it into our dish, I mean chicken biryani, that vessel, you prepare it, it will convert it to a 1 chicken biryani. So now tell me, to prepare 1 chicken biryani, what and all things you needed? 1 masala packet, 1 chicken piece, correct, and 1 kg rice. Now think, suppose there is no 1 masala packet, can you prepare 1 chicken biryani? No, because 1 chicken biryani is always what? 1 kg rice, 1 chicken piece and 1 masala packet. If these three are there, you can say, you combine together, then it will become 1 chicken biryani. Okay. Okay. Now you came to you understood that how many people are visiting from the house, means your father and mother is what going to visit you. So Sunday came, you know that your father and mother is also coming and you are also there. So how many chicken biryani you need to prepare in total? You are going to sit with them and eat, thing like that. So there are 3 chicken biryanis required, 1 for the father, 1 for the mother and 1 for yourself. Okay, so 3 chicken biryanis are required. Now you understood, you calculated this, and now you are going to the shop. Okay, Sunday, think like there is shop there. Okay, don't say that, sir, Sunday there is no shops. Okay, there are some shops there. Okay, so on Sunday morning you are going to the shop and you need to buy. Now tell me, how many masala packet will you buy? You know that 3 people are there. So how many chicken biryani required at the end of the day? 3 chicken biryanis are required. So to prepare 1 chicken biryani, I know 1 masala packet is required. So for 3 chicken biryani, how many masala packet you need to buy? 3 masala packet you need to buy. Similarly, to prepare 1 chicken biryani, how many chicken pieces are required? 1 chicken piece. So you are going to prepare 3 chicken biryani. So how many chicken pieces are required? 3 chicken pieces required. Correct. And similarly, how many kg of rice is required? 3 chicken biryani means for preparing 1 chicken biryani, 1 kg rice is required. So to prepare 3 chicken biryani, 3 kg rice is required. So you have taken the money and everything to buy 3 kg rice, 3 chicken piece and 3 masala packet, assuming that you are going to make 3 chicken biryani. Okay, I hope you understood the story up to this. Now we want, I am stopping at this point. Okay, I am just stopping at this point. Now I am asking you, you can compare this situation with a chemical reaction. Okay, how you are going to compare that? Let me tell. So here I am taking this masala packet as A. Okay, I am taking this as A. Okay, and I am going to assume this chicken piece as B. Correct. Then I am going to assume this 1 kg rice as C. Okay, and I am taking this chicken biryani as D. Hope you understood the denotations. Now we are going to, now think about masala packet went inside, chicken piece went inside, 1 kg went inside. So I can add all these things. Okay, so I will write it in that colors also for your understanding. Okay, so A combined with whom? B combined with C to give you what? D. Correct? Now you, from this you know that 1 masala packet, 1 chicken piece, 1 kg rice gives 1 chicken biryani. So I can say 1 mole of A, listen here, 1 mole of A, 1 mole of B, okay, and 1 mole of C gives you what? 1 mole of D. Is this understandable or not? And this ratio, that is 1 is to 1 is to 1 is to 1, this ratio is called as, in chemistry we call this as molar ratio, or we say this as stoichiometric ratio. Correct? So whether this means you are given 1 mole of A, 1 mole of B and 1 mole of C? No, you are not given this. This is something, the preparation manual. The manual says that to prepare 1 mole of D, what you need? 1 mole of A, 1 mole of B and 1 mole of C. Similar to this, to prepare one chicken biryani, the manual or the YouTube or whatever methods you refer, or the person somebody told, they say that 1 masala packet, 1 chicken piece and 1 kg rice is required for 1 chicken biryani. And what is given to you? Given to you depends upon, I am now comparing again, coming back to the story. So for you, what you need to prepare? 3 chicken biryani. So how much, what and all things you required given to you will be 3 masala packet, 3 chicken piece and 3 kg rice. That is the given. So please understand the difference between stoichiometric ratio and the given stuff. Given is something that is given to you to prepare the output. Understood? So from here you know that 3 masala packet, 3 chicken piece and 3 kg rice is required to prepare 3 chicken biryani. Now I am going to the next part of the story. Please listen. Interesting story. Okay. So I am going to rub this assumption. Okay. Now this was just to compare, to understand why I am saying this story. Okay. Okay. Now I have rubbed this. Now the next situation is coming. You went to the shop. Okay, and in your list you know that 3 masala packet, 3 chicken piece and 3 kg rice is required. You ordered the shopkeeper, sir, I need these things, I am paying the money. Okay, you bought everything and you come to your home. Understood? You come back to your home, or not, sorry, in your hostel, and you started looking into it. So what you have taken? So you have taken, when you are checking, you understood that you have 3 masala packet MP and 3 kg rice is also there. 3 kg rice is there. Okay, but when you are looking at the chicken piece, you could understand that there is only 2 chicken piece. Okay, there is only 2 chicken pieces there. Now what is the problem? Okay, sir, I will go back to the shop and fight. Please understand that shop has closed somehow. Okay, so it might be missed out. Some mistake has happened and at the end of the day you have only 2 chicken pieces. Now you tell me how many chicken biryani you make. So I can calculate like this. Okay, can I rub this? Now I am rubbing this. Okay, so now you are given only this many things. Okay, we will write it in clear way so that for you to get a clear understanding. So now you have 3 kg rice is there. 3 kg rice is there. Now you have 3 masala packet is there. Masala packet is there. And you have 2 chicken pieces there. Okay, you have 2 chicken pieces there. Now you know that you have taken 1 kg rice, 1 kg rice and 1 masala packet you taken and 1 chicken piece you taken. Okay, so that this will become what? 1 chicken biryani. Correct? Super. Now you have taken the next one, 1 kg rice, another 1 kg rice you have taken and 1 masala packet and 1 chicken piece you have taken. Now this has become your second, another chicken biryani, 1 chicken biryani. Now you tell me how many chicken biryani you have made up to now. You have made until now 2 chicken biryanis. Now you are going to make the third chicken biryani. Then what happened? Again you are taking 1 kg rice, 1 kg rice, 1 masala packet, and you are looking for the third chicken piece and you know that that is not available. So can you prepare chicken biryani? So some students say, sir, with the masala packet and kg, please adjust. There is no adjustment. Understand? So if you want to prepare 1 chicken biryani, you need another chicken piece. So I can say that you cannot further proceed with making chicken biryani. And who is limiting you or who is preventing you from proceeding? I can say that, sir, chicken piece is not there. Chicken piece is preventing me from proceeding or preparing chicken biryani. So I can say that chicken piece is my limiting reagent or limiting substance in this case. Understood? Hope you understood. Okay. So I can say that I cannot further proceed. So only 2 chicken biryani will be made, and what will be left with you? I can say 1 kg rice and 1 masala packet is left with me, and this is called unused substance, or in case of chemistry we say unused reactant. Now one question, I have introduced you here a new term called a limiting substance or a limiting reagent. I need to tell many things with respect to this limiting reagent or stuff. I will explain that one by one. I hope you understood this story. Okay, so story mainly tells us that initially you will be given one ratio, or you will be finding some parivam, you say in Malayalam, some fixed values. So based on that only you will understand that this is the constituent for that recipe. So for chicken biryani you understood that you need 1 masala packet, 1 chicken piece and 1 kg rice. That 1:1:1 is your what actually constituents ratio, or in chemistry we say the stoichiometric ratio. Okay, that you should always keep in mind. And given thing, that is what you need to prepare. For preparing actually they will give something. So that is the given substance. So based on the given substance only we will be able to find out what the output. Don't take the stoichiometry and do it here. Okay. Stoichiometry is just to understand that to prepare the output we need this many things in this much ratio. Okay. So I hope you understood this story much better or more clearly. Now if anybody didn't understand, please get back to me. I will make you understand. This is very simple. Okay. Now we will try to see some examples, some example questions, and with that we will try to understand the stoichiometry and its calculations. Okay. So I hope you could read the question. This is the first type of question. So please listen, what are the questions I am discussing is of different types. Please understand or analyze. Please hear the analysis result what I am telling. That is very important so that you can do any questions, that I can guarantee. Okay. So read the question. Consider the below balanced chemical equation. A plus 2B giving C plus D. Okay. If 2 moles of A is given, calculate the number of moles of C produced. This is the question given. Okay. Now, listen here. The question can be framed in many number of ways, as I have told you. Okay. Now, in this question, you know that A and B are the reactant and C and D are the product formed. Correct. And please understand that they have told this equation is a balanced chemical equation. They should tell this because they are using the terms A, B and C and D. You know that there is no such elements like A, B, C and D. So they should give you balanced chemical equation. Whether it is possible for you to balance A, B and C and D, no, you can do that. You cannot do that. Correct. So they should, whenever they are referring hypothetical elements, they should mention it. It is a balanced chemical equation. Okay, so A plus 2B giving C plus D, they are telling it is a balanced chemical equation. And the first step to understand out of this is what they have given to you. So they have given to you is A. They have told that only the quantity of A is mentioned. Correct. If 2 moles of A is given, So here starts the doubts of students. So they will ask, first they will ask, sir, if A is only given, then how we can prepare C and D? Sir, B is not there, right? Normal question, good question, very good question, I can say. So here is where you need to assume the things, or you need to take it in that way. So please listen, if the only one reactance quantity is only mentioned, then you need to take that the reactant B is available in excess. It is plenty of B is available. Okay, now how you can assume that is also I will tell. You remember our chicken biryani story. There you have one masala packet, 1 kg rice and 1 chicken piece is required for 1 chicken biryani, right? You understood that. Now you think like your hostel has a chicken farm is there. There is lot of chickens are there and you have the right to take any number of chickens, no issues. Okay. Now you again rethink. If you are going to the shop, will you think of buying the chicken from the shop? Surely not, because you have the chicken piece available in plenty. Then you will consider only buying what? Masala packet and rice. Then tell me, limiting reagent can come only from masala packet and rice, because that is what not available when you are going to make the chicken biryani. Understood? So this is the way you can think. So here the concept is very simple. Here only the quantity of A is given and you need to know how many moles of C is produced, and if B's quantity is not given there. If you are not given B for preparing C, don't think that sir I cannot prepare. Please assume that B is available in excess. As many B is available. Don't worry about B then. Okay. Now what is the first step? If question like this comes, first step is writing the molar ratio or the stoichiometric ratio. Okay, so the stoichiometric ratio is what? Stoichiometric ratio is equal to, I can say 1:2, 2:1, 1:1. So this is my stoichiometric ratio. So what are the different ways you can tell about this? This means that 1 mole of A combines with the 2 mole of B to give you 1 mole of C and 1 mole of D. This is the meaning of this. After writing this, what you need to do is take the given. Given is what? Given is A. A is only given. What is its quantity? Write it in bracket. 2 mole. Okay, 2 mole. This is what given. Now I know that B is present in excess, so I don't want to consider that. So now tell me with respect to what. Now next thing you need to think is what you need to find out. C only you need to find out. Now we will speak only with respect to C and the given substance. Given substance is A. Now with respect to A and C, how you can write the stoichiometric equation? Tell me. I can say that stoichiometric equation can be written as 1 mole A can give you what? 1 mole C. Correct? This is the stoichiometric equation. You can see 1 mole of A can give 1 mole of C. Why I am not taking B here? Because B is present in excess. So 1 mole of A gives 1 mole of C. Now the question here is how much you are given. 2 mole is what you are given. So I want to convert this into what? 2 mole A. Now tell me, to convert 1 mole of A to 2 mole of A, what you should do? Multiply by 2. So if you are multiplying on the LHS with the 2, what you need to do? Do the same thing on the RHS. So I can say 2 mole of A can give you 2 mole C. So you got the answer. Question is, if 2 moles of A is given, calculate the number of moles of C produced. What will be the answer? 2 moles of C will be produced. And suppose they are asking how many moles of D is produced, means how you will do this? Again, A is given. So I will write 1 mole of A gives. Now with the D they are asking, means I know 1 mole of A can give 1 mole of D. So I will write 1 mole D. So again multiplying by 2, the answer will be 2 mole of D will be produced. And the most important conclusion here is, if only the quantity of one reactant is given. Please, this is a very important rule. If the quantity of only one reactant is given, there will not be any concept of limiting reagent. Please understand that. Marked rule, very important rule. Why? Because limiting reagent is like a competition. You are comparing something. So to compare, you should have minimum two substances. You can see, you can again one more time go back to our chicken biryani story. There we were comparing the chicken pieces with the other case, because if you have one masala packet and 1 kg rice and there is no chicken piece. Understood? Suppose you think there you have a rice form with you in your hostel and you also have a lot of masala packet with you, then those two things becomes excess. Then chicken piece is not a problem. Correct? So if there is only one reactant mentioned, if there is only quantity of only given substance is only of one reactant can be any number, but if they have given only one reactant's quantity, then surely there is no concept of limiting reagent. For example, decomposition reaction. Calcium carbonate decomposes to form calcium oxide and carbon dioxide. There I can clearly say calcium carbonate is the only reactant. So if they have given, then this one, there cannot be limiting reagent concept coming there. Understood? So I hope you understood this problem and this as well. So we will go to the next problem. As the problem progresses, you will keep on understanding the things. So every problem we will analyze it and do it. Okay. Thank you. So hi students, so here we are going to discuss the next question. I have made a slight different values. This is the next type of question. Okay, so read the question here. Consider the below balanced chemical equation. So A plus 2B giving C plus D. Okay, and if 2 moles of A is given and 4 moles of B is given to you, calculate the number of moles of C produced. Okay, so listen here. Here the next case is coming. What is the next case? In the case 1, you are given only one reactant. Not given one reactant, more reactants are given, but the quantity of only one reactant was given. Now here what you are given to you, to prepare C and D, both A and B are given. What is given? If 2 moles of A is given and 4 moles of B is given to you. Understood? In the question they are mentioning it clearly. If 2 moles of A is given and 4 moles of B is given to you. Very clear. Calculate the moles of C produced. Now, in your mind one thing comes, sir, here A and B is given. So A and B can compete and there can be the case of limiting reagent. So sir, how we know that whether here limiting reagent concept will come or not? Or it will always be coming if 2 reactants quantity is given. Now please remember, if 2 reactants quantity is given, there can be a case of limiting reagent as well as there can be no case of limiting reagent. How? I will explain that. Listen here. Now, first I will explain with the classical explanation, then I will give you shortcut. So listen. So as first we will write stoichiometric ratio. So what is the stoichiometric ratio? 1 is to 2 is to 1 is to 1. This is the stoichiometric ratio. So what does the meaning of stoichiometric ratio? Now tell me, 1 mole of A needs 2 mole of B to produce 1 mole of C and 1 mole of D. So this is what is the stoichiometric ratio means actually. Okay. So now we will start preparing C and D in a classical way so that it will be easier. So what is given to you, that also we will first write it up. So given to you is what? A, how much is given to you? A is 2 mole given to you. And B is how much given to you? B is 4 moles given to you. Okay. Now we will start analyzing the question. So I have taken 1 mole of A. Okay. 1 mole of A I have taken. Now tell me 1 mole of A needed how many mole of B to produce 1 mole of C? You know that from this 2 mole of B is needed. So I have taken 2B. Now what you can produce? 1 mole of C. Correct? So I have taken initially 1 mole of A taken with the 2 mole of B to produce 1 mole of C. Now again I am looking back to my kit. I understood that there are 2 moles are there. So 1 more mole of A is remaining. So I have taken that also. I have taken 1 mole of A. Now I am looking for B. How many B is required every time? 2 mole of B is required. Now you know that total 4 was there. So initially 2 moles were used. So now remaining how much? Another 2 mole. So I have taken another 2 mole of B. Now again I can produce 1 mole of C. Now again I am going to prepare 1 mole of A. But whether it is available, I have already used 1 plus 1, 2 I have already used. Now again I am looking for B. I already used 2 mole of B and 2 mole. So totally 4 I have already used. So given to you was 2. The complete 2 of A was used. Complete B, that was 4 mole, that is also used. Now tell me whether there is any limiting reagent or anything is remaining with you. Nothing. Understood? So this can also be a case where you are given more than 1, but at the end of the day complete reactants are used up in the reaction. Understood? So tell me how many moles of C is produced? 1 plus 1, I can say the answer is 2 mole of C is produced. So answer is 2 mole of C is produced. So this is the classical method of doing. But some students will come back and say, sir, if we are keep on writing like this, suppose they are giving 120 moles like that, I need to write 120 times. Not at all practical. You know that. So this was just explaining to you to understand this is how the things are happening. Now I will come to the shortcut. Okay. Now listen here. So to check whether limiting reagent is present or not, what is the best method is, many methods I used to apply. The simple technique is check for this number. This is 1, okay, and this is 2. And what you need to do is take the A, given A here and the B here. Correct, this is A and B. Take the given quantity there, 2 and 4. This is what they have given to you. And what you need to do is convert this into simplest whole number ratio. That's it. Simplest whole number ratio means here divide by 2 and here also divide by 2. So this will get cancels off and this will become 1:2. Easiest way. So if you are getting a same ratio as this ratio 1:2, this is A, this is B, same ratio, then I can say that in that case there will be no limiting reagent. Understood? So very simple, simplest way of checking whether limiting reagent exists or not. So similarly, I can create 1:2 ratio in many ways. For example, I am giving you, okay, listen, I am giving you 6 mole of A and 12 mole of B. Again, with this shortcut, you don't want to do everything. You just want to write A is how much? 6. B is how much? 12. Now make it in simplest ratio. Smallest number out of this is 6. So I will take 6 by 6 and 12 by 6. So this will get cancels off and again you are getting 1 and this has 2. So that is the ratio is again what? 1:2. So 1:2. So if they are giving 6 mole of A and 12 mole of B, I can say that there will be no limiting reagent. Understood? So I hope you understood to check whether limiting reagent exists or not. This is the simplest way. Okay, now come with the third problem. I will explain the third possibility. If limiting reagent exists, how to find who is that limiting reagent? For that also there is a shortcut technique. I will explain you. For this question, anyway you understood that there is no limiting reagent. Understood? So now what we will do next? We will do with our normal way of doing. What we will do? We know that here 2 mole of A and 4 mole of B is given to you. Okay. Now you want to calculate the number of moles of C produced. If no limiting reagent is there, you need to take either A or either B. I will tell why. Now suppose I am taking only A. Then I know that if I am taking A and I want to calculate C, so I will consider A and C only. Then as per the equation, I know that 1 mole A can produce 1 mole C. Correct? So now tell me how many moles of A is given to you? 2 mole. So to convert this, multiply by 2. So this will become 2 mole of A. Now if you are doing this on the LHS, do it on the right hand side also, multiply by 2. So you will get 2 mole C. So answer is what? 2 mole C. That's it. Suppose some students say, sir, I am not taking A, I want to take B. Okay. Then what you need to do? Again, please rewrite the fundamental stoichiometric equation. Now you want to relate this between B and C. What you need to do? Underline these two. Then as per the equation, you know that 2 mole of B can give you 1 mole of C. Correct? Now, this is the fundamental equation. Okay, how many moles are given to you? Okay, sorry, this is the old... So here, how many moles are given to you as per the equation? 4 moles are given to you. So how to convert this 4 mole? So why I am converting this to 4 mole? Because you are given 4 moles. You need to use the 4 moles, right? So to convert this into 4 mole, so multiply by 2. So do the same thing on RHS also, multiply by 2. So this becomes 2 mole C. So answer is what again? 2 mole C. That is what I have told. If you take either A or either B, if there is no limiting reagent, again I am saying, if there is no limiting reagent applicable or possible, then you can take either A or either B to find out the number of moles of C produced. So this is how 4 mole of B can give what? 2 mole of C, because 4 mole of B is what given to you. Correct? Or you can find in terms of A. If you finding in terms of A also, then it becomes 1:1 ratio. So if you make it this to 2 mole, given substance is 2 mole, then the product will also become 2 mole of C. That is the importance of this method. And please remember, this method is applicable only if the equation is balanced. If somehow, if you have forgot to balance the chemical equation, what will happen? The whole stoichiometric ratio will get into wrong and your answers will go wrong. So if you are following this method, first ensure that you are able to balance the given chemical equation. Understood? So we will go to the next type of questions and we will try to analyze that. Okay, so in all these questions I am giving you the A and B in terms of what? Mole, and I am asking you in terms of mole. Now I have earlier explained they can give in any terms. Sometimes A will be given in number of molecules and B will be in mole. Sometimes A will be given as volume and B will be some gram molecules, and ask you to calculate C in terms of mass. Anything they can ask. Since it is A, B and C and D, I am not introducing other things. I am introducing only moles. I can create thousands of questions. But we will try to see different types of questions with the actual real equation also. This is just basics for you to understand the concept in clear. If you are understanding the concept very clearly, I can assure you any questions you can do. That is the easiness of physical chemistry. If you are understanding the concept, the correct point you are understanding, that's it. Method is immaterial. You can follow any methods, but you will get the exact correct answer. So I can guarantee you for JEE and Neet, you can do any questions. Okay, this is all done. This is what it is. There is nothing more than this. Okay. So we'll go to the next question. Okay. So I have created the next question. This comes under the third question. So in the first question there was only one reactant, there was no limiting reagent. In the second question the given substance was for two reactant and still there was no limiting reagent. I told whether to check the method also to check the limiting reagent there or not. Now in the third question we will try to see there exists some limiting reagent. Why also we will see it. Okay, now read the question. Consider the below balanced chemical equation. Okay, A plus 2B giving C plus D. Okay, if 2 moles of A is given to you, and what is the change I made? Instead of this I made to 6 moles, and 6 moles of B is given to you. Calculate the number of moles of C produced. Understood? So this is the question that is given to you. Correct? So what is the first step of doing? So again here also we will go by classical method first, then we will go to our actual method. Okay, listen. So listen here, what is the stoichiometric ratio? Tell me 1 is to 2 is to 1 is to 1. So this is my stoichiometric ratio. Clear? Now given, so A, what is the given substance? Okay, always write given, otherwise you will get into confusion. So given to you is A. How much moles given to you? 2 mole. Correct? And next reactant given to you is B, and B, how much mole is given to you? 6 mole. So classical method, how? We will take one by one and we will prepare it, right? So you will do like that. Okay. So first I am taking 1 mole of A. I know that 1 mole of A need 2 mole of B. So I am taking 2 mole of B. It is present because 6 moles are there. So if I take it like that, I can prepare 1 mole of C. And 1 mole of D will also come. Okay. Since D is not asked, I am not telling that. Okay. Now next thing. Again I am looking again 1 mole of A. I am taking, okay, it is there present because 2 moles are there. So I have taken 1 mole of A already. Remaining 1 mole is there, I have taken. Now again I am going to take 2 mole out of this. So I have checked it out. Initially 6 moles were there, 2 moles used up. So 4 mole were remaining. Again 2 mole I am taking it. So 2B, that gives me 1 mole of C. And again now I am going to prepare C, means I have checked it out. Complete 2 mole of A is used up. So A has become what actually? 0. Nothing is available. But I am checking B, means already how many is used up? 2 plus 2, 4 is used up. So I can say 6 minus 4, 2 is remaining. But my question again comes back to here. Please consider this story to our chicken biryani. You have B is there. But whether A is available, A is 0. So who is limiting you from preparing C? I can say A is not present. So A is limiting me. So my limiting reagent is who here? A. So I can say that limiting reagent is that reagent which get completely used up in the reaction, because A is completely used up. There is nothing remaining. But you can see B is remaining something. Okay, 2 moles of B is remaining. So tell me how many moles of C is produced? Again the answer is 2 moles of C is only produced, 2 moles of C. And what is left in the medium? How much reactants are left in the medium? I can say 2 moles of B is left in the medium. Understood? So to prepare C, I need A, but A is not available. Without A, I cannot go and prepare C. This is the classical method. Understood? Now we are going to our technique, because this like values and all they will not give to you in exam. They will give in different ways. Some will be mass, some will be number of molecules, some will be volume. Whatever they are giving, convert that into number of moles and do it like this. That's it. Okay. So we will go into our classical method. Classical method states that first we will check about whether limiting reagent is there or not. That is the first thing. So that is the first check you can make, if limiting reagent is present or not. How you do that? Take given mole of A, you know that is 2. Take the given mole of B, that is 6, and convert this into simplest whole number. How you do that? Divide by 2, take the smallest number out of this and divide both numbers. So this will get converted. So this becomes 1:3. It is not 1:2. From this I can understand that this simplest ratio is not same as the given stoichiometric ratio. Then I can confirm that this reaction or with this given substance, there will be somebody who is limiting me. There will be a limiting reagent. Understood? Now, next technique is what I have told you. The method to find the limiting reagent very fast. Okay, with the classical method, you every time you need to write, and at the end of the day you can find it out. Suppose they are giving bigger amount of moles, can you write it every time? Not possible. So we will find some shortcut technique to find the limiting reagent in a faster way. Listen here. So this technique I have explained is just to check whether limiting reagent is there or not. Now I am going to tell you a technique to identify out of A and B who is the limiting reagent. Okay, so that technique is very simple. What you need to do is take the given substance as such in mole. 2 mole is given A, this is for A, and 6 mole of B is given. Okay, now what you need to do is you don't want to write mole here. Okay, may create confusion. Okay, take that numbers 2 and 6. Now take the stoichiometric value of A. What is that? 1. Take that one and divide this. And similarly, take the stoichiometric value of B, that is 2, and take this 2 here and divide this number. So after division, I understood this is 2 and this is 3. This is 2 and this is 3. And check which number is small out of this. I know that smaller number is 2. Understood? The smaller number. This is the smaller number. Or 3 is greater than 2. So smaller number is 2. If which one is the smaller number and this number belongs to whom? This number belongs to A. Then I can say that A is the LR. A is the LR. LR means limiting reagent. Very simple. Understood? So what we have done, one more time I will explain. Take the number of moles given here as such for A and B. Take the stoichiometric value of A as such and divide this number. Take the stoichiometric value of B as such and divide this number. That means the given quantity. And take the numbers. After division you will get 2 numbers and check which one is a smaller value. And this smaller value belongs to whom? If it is A, then I can say A is the limiting reagent. Understood? So this can be directly applied and check whether limiting reagent is there or not. Understood? In one shot you can get who is the limiting reagent also. Suppose if you apply this method directly and you obtain 2 and both places you are getting 2, 2, then what does that mean? There is no limiting reagent in that case. Correct? Very simple to identify who is the limiting reagent. Okay. Now this is a third case where limiting reagent is present. Now if in the question, if you identify that limiting reagent is there, then every other thing will depend upon the limiting reagent. Correct? Now how you will compare this statement with chicken biryani? You know that chicken piece is limiting you from preparing chicken biryani. Then you can say that if I have enough chicken piece, I can utilize the remaining rice. If I have the enough chicken piece, I can utilize the remaining masala packet. If I have enough chicken piece, I can prepare the chicken biryani. So everything is depending on the limiting reagent. Correct? So what I will do, here I understood that A is the limiting reagent. Now I will write in terms of A everything. Please listen how I am doing this. Very, very important. Now I understood A is the limiting reagent. Now what I will do is I can write everything in terms of A alone. How I will do that? How I am going to do that? Listen. 1 mole of A can give you, tell me 1 mole of A can give you, as per your stoichiometric ratio, 1 mole of A can give you 1 mole of C. Correct? 1 mole of A can give you 1 mole of D. Correct? Now 1 mole of A needs, okay, this is producing, produce, this is produce, and 1 mole of A needs what? 2 mole of B. Everything is based on limiting reagent then. Now in the question they can ask you anything. Calculate the number of moles of C produced. That is what in this question they are asking. So I can say 1 mole of A produce 1 mole of C. Now in the question what they have given to you, 2 mole of A. Now tell me, if I am converting this to 2 by multiplying with the 2, what will happen? If I am multiplying with the 2, so this becomes 2 mole of A. Then what you need to do here also, you need to multiply. Why I am multiplying here? They are asking me C. So I am multiplying here also with the 2. So my answer will become 2 mole C. So answer is 2 mole of C. This is what we have found out by our classical method. Okay, wait. Now in the question, suppose think that they have asked calculate the number of moles of D produced. If you follow this method, you can calculate anything. Now think, if you want to produce, calculate the number of moles of D produced. What you need to do? Suppose what is given to you? 2 mole of A. So 2 mole of A can produce, now tell me 1 mole can produce 1 mole of D. So 2 mole of A can produce what? Into 2. I know that is 2 mole of D is produced. And now tell me how many, 1 mole of A needs 2 mole of B. So tell me 2 mole of A needs, multiplying by 2 here, multiply here also. So I can say 4 mole of B is needed. So this is the simplest way. Identify the limiting reagent and convert this. First you write it in terms of stoichiometry, then check how many moles of A is given, 2 moles. Then for that 2 moles, how many other steps are required? That's it. How other steps are produced and other steps are required. Identify that. I understood that if you are using 2 mole of A, that is why I am writing in terms of A, because A is the limiting reagent and he determines how many quantity of others needs to be produced or utilized. So I can say that 2 mole of A produces 2 mole of C, 2 mole of A produces 2 mole of D, and 2 mole of A utilizes, needs 4 mole of B. Understood? Now in this question, suppose they are asking you, calculate only the remaining reactants present in the question. Suppose like that they are asking, calculate only the remaining reactants. I know that reactant is, limiting reagent is A. So A will not be remaining. Correct. Limiting reagent means it will be completely used up. So who is the other reactant remaining? B should be the other person. How much it is remaining? I know that 4 mole of B is used up because 2 mole of A needs 4 mole of B. So how many moles of B is given to you? 6 moles of B is given to you. So tell me how many moles will be remaining in the reactant medium or excess reactant. Excess reactant will be 6 minus 4 and that is equal to 2 mole of B will be remaining in the reactant medium. Or sometimes they will ask, calculate the total number of moles present in the reaction medium. Then you need to consider the product also. I know that at the end of the day, after the reaction, 2 moles of C will be there, 2 moles of D will be there, 4 moles of B will be there. No, 4 moles of B is used up and remaining is how much? 2 moles of B. So totally 2 mole of C plus 2 mole of D. So totally 4 and again 2 mole of B is remaining in the reaction medium. That 2 will also needs to be added up and 2 plus 2 plus 2 actual answer will become 6. 6 moles will be remaining in the reaction medium. Remaining means after the reaction what is present after all the reaction. Understood? So I hope with these 3 questions I tried to explain all possible 3 possible ways and I still didn't explain the different way the given substance can be given. In all these questions I have given you A and B in terms of moles only, that is for easiness. They can give in any ways, any possible ways. We will try to see some questions and we will try to do it. Okay, in any ways if they are giving, my method is very simple, convert that into what? Number of moles. And also find the products also in number of moles. And suppose in the output they are, instead of asking calculate the number of moles of C produced, they are asking calculate the number of molecules of C produced. What you need to do? You know that 2 moles of C is produced and I know that 1 mole of C is how many number of molecules? 6.022 into 10 power 23 and if it is 2 mole means 12 into 10 power 22 molecules of C is produced. That's it. So simple. At the end of the day, convert the mole to desired parameter, whether it be number of molecules or mass or number of gram molecules or volume, whatever be it. If you do like this, fatafat, it will get completed in a very fast way. And please practice this. This is the simplest method. Or if you are keep on writing with the formulas and everything, it keep on going like that. But this give you confidence. This is a method basically. If you remember this method, any question you can do it. This is a guarantee. Okay. Okay, students, so we will do some questions with all possibilities. We will try different possibilities. So I think with doing some 5 to 10 questions, you will get a clear idea how to proceed. So go through this question very simply. What volume of carbon dioxide at STP will be evolved when 1 gram of calcium carbonate undergoes decomposition reaction? This is the question. Okay, so let me first think of what is the reaction basically. So I know it's a basic simple reaction. So if it is a simple reaction in exam they won't give it, but if it's a tough reaction usually they will give it. Okay, so calcium carbonate decomposition means CaO with CO2. Okay, this is the reaction I understood. Okay, now first thing is balancing the equation. I know calcium 1 mole, so here also 1 calcium is present, here also 1 calcium, here 1 carbon is present, here also 1 carbon, oxygen 3, here 1 plus 2 3. So it's a balanced chemical equation. Okay, now please read the question. What volume of CO2 at STP? So they want the product, they want whose information? Carbon dioxide's information. And in what terms they want that information? They want that information in volume. So you understood the product, you want the output in terms of volume. Okay, so this is one guy, you want to find it out. And what they have given, I told you, if there is only one reactant, they will be giving only that. There is no much doubt in that. So they have given is calcium carbonate, and in what quantity they have given? They have given in mass, that is 1 gram. Correct. So this is what they have given. Okay, and what you need to find out? Carbon dioxide in volume. Okay, so as per our understanding how to do this, first thing is, you know that there is no limiting reagent since there is only one reactant. Okay, that's it. Now we will talk now with respect to calcium carbonate and what? Carbon dioxide. We don't want to take calcium oxide because nowhere in the question they have mentioned it. So as per our understanding, the stoichiometric ratio is 1:1:1. Correct. And I can say that 1 mole calcium carbonate produces how many mole of carbon dioxide? 1 mole CO2. This is a fundamental I used to write because these two needs to be related. And now comes the things. So my answer I got it, whether I have got the answer? No, this is the stoichiometric ratio. Now given is what? 1 gram. There are different ways to proceed from here. I am telling all the step number 1 or first type I am telling. Either I know that what is given to me 1 gram. Either I can convert this 1 gram to number of moles and find out the corresponding number of moles of carbon dioxide produced. Then convert that number of moles to volume to get the answer. This is one step. First I will do it in that way. Please listen, all these are methods. Whichever is comfortable for you, you do it in that way. Okay. So I need to convert 1 gram to number of moles. How I will do that? I know that my fundamental step, I know that 100 gram, that is the molecular mass of calcium carbonate. 100 gram of calcium carbonate is equivalent to 1 mole of calcium carbonate. Please look back to my mole concept in terms of molecules. There I am telling 1 mole of any molecule is equal to molecular mass in grams. Please go back there. So 100 gram of calcium carbonate is 1 mole of calcium carbonate. I want to know 1 gram of calcium carbonate is how much mole. So to convert this into 1 gram, what should I do? Divide by 100. So this will become, when you divide by 100 here, this will become 1 gram. And when you divide here also by 100, what will happen? This will become 1/100 mole. Correct. So 1/100 mole is nothing but 0.01 mole. Okay. So I got that. Okay. Now I know 1 gram is equivalent to what? 1 gram of calcium carbonate is equivalent to 0.01 mole of calcium carbonate. So I want to know 0.01 mole of calcium carbonate will give you how many mole of carbon dioxide. So I want 0.01 mole calcium carbonate. So how to convert 1 into 0.01? Multiply by 0.01. So when you do it here, do it on the RHS also. multiply by 0.01. So what will happen if you multiply here? Then this will get converted to 1 into 0.01. So you will get the answer as 0.01 mole carbon dioxide will be evolved. So in terms of mole, the answer is correct. 0.01 mole of carbon dioxide is evolved. Correct. But are they asking you the carbon dioxide in terms of mole? No. They are asking you in terms of volume. So what you need to do? You need to convert this mole to volume. I know that at STP, I know the relation 1 mole of CO2 at STP is equivalent to 22.4 liter CO2. This is the fundamental relationship I know. Please refer to old lecture classes. Now, how much mole you have? 0.01 mole. So I want to convert this into 0.01 mole CO2. What you should do? 1 to 0.01 mole. You multiply by 0.01. Do the same thing on here also, 0.01. So what will be the answer? 22.4. Okay, 22.4 into 1 is 22.4, but 2 places left. So that means your answer will be 0.224 liter CO2 will be evolved at STP. So the answer is 0.224 liter of carbon dioxide will be evolved at STP. This is one method of doing this question. So here many students used to complain that, sir, I understood the method, but the problem here is I am converting 1 gram to mole and I am calculating the number of moles in mole, then I am converting the moles again back to volume. So 2 conversions I need to do. Sir, is there any simple way further to make it more simpler? This is easier if you know to convert very fast. That's why I say in the first classes I have told you the conversions between different units. If you learn that thoroughly, very fast in fingertips, this becomes easy. Other way of doing this question also I will explain. Please listen. So this is one method of doing it. The other way around is this one. Listen, I'm just rubbing this. Okay, in the other method, there is no much change here. First step will remain the same. 1 mole of calcium carbonate will give you 1 mole of carbon dioxide. But hereafter what I will do is, I will do it here itself. Tell me 1 mole of calcium carbonate is equivalent to how much mass in grams? You have learned that is molecular mass in grams. So this will be equal to 100 gram calcium carbonate. I will do it in that way. Why I am converting mole to gram here? Because in the question they have given in terms of grams. That's the reason why mole I have represented in terms of grams. Now coming to here, whether do I need to convert 1 mole to here also gram? If needed I can do, but check it out here. Carbon dioxide you need it in what quantity? Volume. You need it in volume. So what you need to do? 1 mole of carbon dioxide is equal to how much volume? Do it in that way. 1 mole of carbon dioxide is equal to, at STP, this will give you 22.4 liter carbon dioxide. Super. Now the given terms is in gram. Okay, that is also here in gram for me. Output you want to find it in volume. I have made it in volume in one single step. That's it. But in terms of 1 mole, whether I have got the answer? Now I know 1 mole, that is 100 gram can give you 22.4 liter of carbon dioxide. To me the question is 1 gram can give you how much? So now tell me how to convert 100 gram to 1 gram. So divide by 100. When you do it dividing by 100 over here, divide here also by 100. So I will get the answer. When you divide on both sides, I can get the answer. 1 gram calcium carbonate will give you, dividing by 100 here, will give you 0.224 liter carbon dioxide at STP. Look here how simple it is. I got the same answer, 0.224 liter carbon dioxide. So this is the easiest, or just you know it, simply applied. First you do it in 1 mole, then check it out in given terms how you to convert, do it and do it. Why I have converted this to gram? Because the given substance is in gram. Why I converted this to liters? Because output they are asking you in volume. That's it. Understood? So I can create n number of questions out of this. So this is the way you need to do it. When you are doing like this, the whole process will become easy for you. Understood? So we'll go to the next question. Okay. Okay, listen here. The question they have asked here is how many molecules of water will be produced, okay, if you were given 2 moles of hydrogen and 44.8 liter of oxygen gas at STP. So what they were talking about? They were talking about water molecule. From where it is produced? It is produced from hydrogen and oxygen. So first let me write the equation. I know that hydrogen, that is H2 plus O2 giving you H2O. So I know that first step is writing the equation, but make it balanced. Don't forget that step. If you are going by stoichiometric method, there is another method is also there. He'll tell that. So if you are going by stoichiometric method, the first step is balancing the chemical equation. So you could see 2 hydrogen, oxygen 2 is there. So what I should do? So if I am making it 2 here, no, that is not correct. This becomes 4. So I am making it 2 here. So now you see here 2 oxygens are there, but 4 hydrogen. So I will add 2 here. So 4 hydrogen, 2 oxygen, 2 oxygen. So this is my equation. And we know that oxygen, they are telling it is in gas. So we will say it in gas. Okay. So some people will ask, sir, whether water is also in gas. If they are mentioning it is gas, please remember it is water vapor. Else you consider it as liquid. Okay. That is one important thing. Okay, so now hydrogen should always be in gas. There is no form. So this is what you are getting. This is my equation. Fine. Now the question here is, what is the stoichiometric ratio? You know that the stoichiometric ratio is 2:1:2. Correct? 2:1:2. So how will you interpret this? 2 mole of hydrogen needed 1 mole of oxygen to produce 2 mole of water. This is my interpretation. Now what is given to you? Given is very important. So given to you is hydrogen given to you. Super. Hydrogen. How many mole of hydrogen is given to you? 2 moles of hydrogen given to you. And oxygen is also given to you. So there can be a case of limiting reagent. And oxygen is given in volume. That is the biggest. Next thing, 44.8 liters given to you. So how beautiful this question is. Listen, A is given in terms of moles. I mean hydrogen is given in terms of moles. Oxygen is given in terms of volume. And they are asking you to find out the water in terms of molecules. Now, why a examiner put question like this? Here, by putting a question like this, he can ensure that the student knows the interconversion between all these units. He don't want to ask a question from the initial section to check whether you know the interconversion. They can create that question inside this question. Or if it is an easy question, they can give all the things, or hydrogen in moles, oxygen in moles, and ask you to calculate the water also in moles. That they won't do. If they want you to consume time, they will put questions like this. So then we will categorize this question as a medium question. But you can convert this as easy question. How? If you know to interconvert these values very fast. This is where coaching helps you. If you are not undergoing a coaching, I mean training, I won't say coaching, training from somebody who is experienced. You won't understand this. You will experience all these in exam hall. In schools, they will just tell something. They will explain some problems. But they won't tell all these different techniques of putting the questions and making you consuming time and other things. So this is where I could help you a lot. So now I can say that when these things are in different quantity, you will be taking time. So how we can do it as fast as possible. So that is why I am telling, please learn what I have taught you in the initial classes as many times as possible. Do the revision as many times. Then I can say this chapter is not guaranteed. This whole physical chemistry is guaranteed for you. Understood? Because this is the crux of physical chemistry. Okay. Okay, I am not giving much further lectures. So we will meet all you in our class, and we will have a much more interaction. So just now I am going to my technical stuffs. So listen. So hydrogen here 2 moles and oxygen it is 44.8 liter is mentioned. So I want the output in number of molecules. Okay, so I will always prefer, if I go as fast as possible, means I will try to do this question in terms of moles itself. I will tell why. Because one of the given quantity is moles. So as per this, okay, before doing that, I need to check whether limiting reagent is there or not. Okay, how will you do that? I am not going to check whether limiting reagent is there or not. I am going to actually find the limiting reagent. So in that case, if it is becoming equal, then I can directly know that there is no limiting reagent. So I am cutting one step. Okay, so given quantity of hydrogen I have written here 2 moles. Okay, the next question, oxygen is given in 44.8 liters, sir. Then what we need to do it? Convert that into number of moles. I know that 1 mole is 22.4 liters. So 44.8 liter means for 22.4 into 2 is 44.8 liters. So I know that oxygen is 2 moles. Okay, if you are still not knowing, please write here as such. 1 mole of O2 is equal to 22.4 liter at STP. So 44.8 means I should multiply by 2. Then this becomes 44.8 liter. Here also multiply by 2. So this becomes 2 mole of oxygen. Like that you can do initially, but later on this values I will make you by heart. 44.8 into 3 means what is the value, into 4 means what is the value. Some common things that will help you do the calculation as fast as possible. Okay. Okay, so I hope you understood how the 2 moles of oxygen is coming there. Now what is the next step we need to do? Take the 2, divide by the stoichiometric value. 2 I am dividing, here I am dividing by 1. So this value will become 1 and this value is 2. Now tell me who is the smaller number out of this. Smaller number out of this is 1. That 1 belongs to hydrogen. Then I can say hydrogen H2 is my limiting reagent, LR. H2 is my limiting reagent. So if I know hydrogen is the limiting reagent, what is the next step I should do? I should write everything in terms of hydrogen. That is my next step. Okay, so I am rubbing all these things. So how will you write in terms of hydrogen? I will write it like this. Now tell me with respect to stoichiometry. First I will write. With respect to stoichiometry I will write like 2 mole hydrogen. 2 mole hydrogen can give you 2 mole water. Now tell me producers. This is one is reactant and other is product. That is why producers is coming. And next guy is oxygen. So he is a reactant. So I can say needs. Okay, 2 mole hydrogen needs 2 mole hydrogen needs 1 mole oxygen. Correct? 1 mole oxygen. Now this is based on stoichiometric ratio. Now what is given to you? How many moles of hydrogen is given to you? You are given luckily here the stoichiometric value of 2 is coinciding with the given value. Given value is what? 2 mole of hydrogen. So do you want to do any extra manipulation here? No. That means 2 mole of hydrogen can produce how many mole of water? How many mole of water? 2 moles of water. But whether I have got the answer? Because the answer is in 2 moles. I want to convert this into what? Molecules. So molecules means I know 1 mole is equal to Avogadro number of water molecules. So 2 mole means what? 2 into Na. 2 into Avogadro water molecules. Water molecules. So answer is clearly speaking 2 into 6.022 into 10 power 23, and the answer is 12 into 10 power 23 water molecules. Okay. So in the question they are asking you how many molecules of water. I have found it in number of molecules of water. Can you now in this question we will try this 2 moles in different way. Now tell me in terms of number of molecules of water, we got the answer. Okay, now we are extra trying to analyze the question and learn more. Okay, so 2 moles of water I have found out it is 12 into 10 power 23 water molecules. That will be the option present there, or either they will give 2 Na. Anything can be given. Now suppose they are asking you in terms of number of gram molecules of water. Instead of how many molecules of water, they are asking you calculate the number of gram molecules of water. This is how I am telling different types of questions can be created. You know that number of gram molecules of water can be asked. They can ask you what is the mass of water produced, or they can ask you what is the volume of water produced if water is a gas at STP. So again they can create the question, or even they can ask you how many moles of water can be produced, like that. Now here the given quantity is in what, actually moles and volume, or they can give here moles and this also in moles. They can give moles and this in number of molecules, moles and this in gram molecules, moles and volume, and they can further, this can be given in volume and this can, so like that many possibilities they can give, but that is not a problem for us. We just follow this method as such. Okay, so tell me in terms of gram molecules. I know that 1 mole of water is equivalent to 1 gram molecule of water. So what will be my answer here? Then 2 mole of water will be equal to 2 gram molecule of water. So if they are asking you in gram molecules, my answer will be 2 gram molecules of water, because 2 mole of water is equivalent to 2 gram molecules of water. Suppose they are asking you the question, or they are asking you what is the mass of water produced. In mass they are asking you. I know that 1 mole of water has a mass in grams is equal to 18 gram. I have learned this from my fundamental concept. 1 mole is equal to molecular mass expressed in grams, or you can say molar mass in grams, both are correct. So 18 gram I know. So tell me what is 2 mole. 1 mole is equal to 18. So convert it into 2 mole, multiply by 2 on both sides. Then the answer will be 36 gram of water will be produced. 36 gram of water will be produced. Now think about the third situation. They are asking you in volume. What is the volume of water produced at STP? Then water is a gas or a vapor. Then in that case, I know 1 mole of water at STP can produce 22.4 liter at STP. Now 2 mole of water, 1 mole is 22.4 liter. 2 means multiply by 2 on both sides. Then the answer will become 44.8 liter of water vapor at STP. That will be my answer. Understood? Number of molecules we already found it out. 1 mole means Avogadro number, 2 mole means 2 times Avogadro number. So this is the way they can create the question and make you do it. Understood? So I have almost explained all possible methods. So now we will go to next questions, different types of questions from this, and we will practice different questions so that it will become more comfortable for you. Okay.